Hi everyone, and welcome to today's webinar. I'm Michaela Williams, and we'll be discussing Canary releases on Kubernetes with Spinnaker, Istio, and Prometheus. Today's presenter is Slava Koltovich, CEO at Kubler. If you have any questions, please post them in the chat and we'll make sure to address them. Okay, let's get started.
All right. Hi, everyone. Thank you for joining our webinar today. I will start from a brief introduction of what Kubler is or what Kubler does. So we we provide the Kubernetes management platform designed to deploy and run your production quality Kubernetes clusters across different environments, meaning all public clouds, VMware, and any other, on-prem or data center solutions. Going back to the subject, so let's talk about Canary today. Why do we even do Canary releases when we do a lot of techniques of how to check our software before it goes to production? So the primary reason we still want to verify how our software behaves in production before we switch over to the new version is really because we cannot, there's no two environments that are completely the same. So we cannot move everything from our production environment to our staging environment. And so when we, test our application environment, we cannot be, 100% sure that it will work in production. And it's not such, that big of a problem if we release, let's say, one or two monolith application every 6 months. So, I believe all of us are quite familiar with those, weekend releases. But as we switch to microservices architecture and the number of components grows and, reach hundreds, if not thousands, so this approach does not work anymore. So we have to automate as much as we can. We cannot manually verify every possible deployment to production. So we need a mechanism in place that will ensure that the new version, which is properly tested again through, integration tests, end-to-end tests, probably review it in your staging environment, runs well in production. So before we jump to Istio and Spinnaker and all other buzzwords, so let's see what we can do on a pure Kubernetes and why we need all those tools to implement the proper Canary releases on Kubernetes. So as you know, Kubernetes has a set of entities or objects that allow us to run and publish our application. So on this diagram, you see very schematic, presentation of two applications. Application A running in single pod here, and application B, which is deployed through a deployment version 1.0. So we consider it our first version of our application. And we have two pods running, and then we have service, which is the internal, let's just simplify it, it's internal load balancer provided by Kubernetes that does simple round-robin load balancing for all incoming release. So if our application A called service for application B, so every second request will go to the second pod and so on. So what we need to do if we want to release a new version to this cluster, a new version of application B, and what we need to do in order to enable some kind of canary technique with that. So what we do in this case, we deploy the second version of application, which is run by separate deployment. So we don't upgrade the first one because that will trigger a Kubernetes rollout upgrade, not exactly what we want. So we deploy the second version side by side. We deploy it with one pod here, but we connect it to the same load balancer, to the same service for application B. So what's happening now is that we have three different pods running for application B, and so every time we hit a service for application B from application A, our load is distributed like, 1/3 would go to the new version and 2/3 would go to the first version. So that would give us a chance to, let's say, or send 1/3 of our traffic to the new version and see how it behaves in comparison to the old version before we do, a larger switch. So if we are happy with the result, we manipulate the number of pods. So in this case, we move more pods towards the new version and less pods in the old version. So if we look at this diagram, we can say that 66% of traffic will go to version 2, where 33% of traffic will go to the version 1. And we can run in this configuration again for some time, measuring results and see how new version behaves in comparison to the old version. And that could be everything: performance, error rate, the responses, and so on and so forth. So basically, any type of measures you want to put or that qualifies that our application runs well can be used here. So now, if we're happy with the results of this breakdown, we can do the final switch, which means that we completely remove the previous version, and then all traffic will go to the new version for application B. So, and that completes the Canary release. And next time we need to release the version 2.1 or 3.0, so we do the same over and over again. So now, what I want to mention here is that really that this technique is somewhat limited by Kubernetes traffic routing capability, right? So as I explained, so the only way we can shift traffic from one version to the other version would be to manipulate a number of pods between those two versions, which means that if we really want to achieve, like 1% testing, 2% testing, and so on, we need to run 50 or hundreds of pods of the same application, which is not always the case. So we need a better way to manage our traffic inside Kubernetes cluster if we want to achieve a real Canary deployment. And that's why we need Istio. So I'm pretty sure many of you are familiar with Istio service mesh. Probably one of the most popular service meshes on the market on Kubernetes space today. And Istio does a lot of different things that quite helpful if you run microservices application or microservice-based application on your environment. However, for our specific use case, we will focus on Istio traffic management capabilities. So if you see the diagram here on the slide, so the way Istio works in comparison to Kubernetes is Istio shifts the traffic routing towards clients themselves. So in our previous diagram, our client was sending all the requests to the same endpoint, and then endpoint, which was Kubernetes load balancer, was distributing those requests towards different versions of applications. In Istio, we have a central component which basically gather all the information of, let's say, all the applications and versions and so on available, and also has a set of rules that define how the traffic or how requests internally should be distributed, and then those rules are pushed to the so-called sidecar or the proxy that attaches to every application pod that runs in your environment, and that kind of process or proxies all the incoming and outgoing requests for your application. And so the proxy decides where and how to send the outgoing requests. So let's see how that changes the Canary process that we think for Kubernetes entities if we introduce Istio in place. So the first one as you can see here, so we changed. So we add pilot, which is the one of the Istio central components here. That's where the traffic rules, let's say, accumulated and distributed to specific or individual proxies attached to your applications. Then we have the same application A, and we see envoy proxy attached to it. And then we have application B already in the Canary stage or first Canary stage when we still run the two different deployments, version 1 and version 2. And then version 1 has 2 pods and version 2 has 1 pod, but it doesn't really, it doesn't change the way traffic is distributed. It's only changed the way, how many requests every pod receives. And the way we do it here, so we also created so-called virtual service for application B, so that kind of defines how the traffic has to be distributed. So on this diagram, and on this YAML file that we see here, we kind of say that 99% of the traffic should go to version 1, and then 1% of the traffic should go to version B. So, and we don't need to run hundreds of pods for that. So again, as we run it in this configuration, we should do observations and measure important metrics from the new version of application compared to the old version of application. And if we are happy with the results, we can move forward and let's say do 50-50, or in real life that would be probably 1%, 5%, 10%, 25%, and so on. Or it can really increase by 5% every hour or 2 hours, depending on your release strategy. So here in our case, we changed the virtual service definition to distribute traffic 50-50 between two different versions. At the same time, as you can see, the number of pods hasn't changed. So, well, that can be dangerous because now you use 2 pods to handle 50% of the traffic for version 1 and only 1 pod to handle the same amount of traffic. But scaling in this case is done separately and can use Kubernetes horizontal scaling capabilities. So the number of pods for each version will increase automatically as this version of application experience more and more load. So same here, we're running this configuration. When we're ready to switch, we deploy a new version of virtual service that basically says now all the traffic goes to version 2, and then we delete version 1 of application from the cluster. So with Istio, we get what we needed in terms of traffic management, in terms of traffic splitting. So now we can do any kind of configuration we need, 199, 298, 50-50, and so on and so forth. Doesn't really depend on the number of pods. We can run 1 pod for version 1 and 1 pod for version 2. It still will work because the traffic splitting is done on the client and doesn't really depend on the number or on the round-robin mechanism. So the one thing that's still missing here is that as we went through the slides, so there is an orchestration that happens, which is deploy a new virtual or deploy a new version, deploy a virtual server service with 1% of traffic distribution, monitor the results, analyze the results, make a decision, move forward, deploy the new version of virtual service, and so on and so forth, which needs to be scripted somewhere. And for this, we introduced Spinnaker into our environment. So for those of you who don't know, so Spinnaker is the continuous delivery tool, was initially built by Netflix and open source back in 2015. Currently has a huge community of companies contributing to it, including Google, Microsoft, AWS, Pivotal, and many others, as well as very impressive users, where Google itself uses it for some internal services. Apple uses Salesforce, and many other big or large software and enterprise companies use it today for cloud deployments and Kubernetes deployments. So as we introduce in the proper CI/CD process, one of the questions that often pops up: how do we navigate, or how do we orchestrate the whole process using different tools? And so here you can see very schematic representation of the CI/CD process using Jenkins and Spinnaker, and this is the combination that we recommend our customers to use. So in our case, or in this case, Jenkins is used to run test and build process. Basically, every commit that goes to your Git repository triggers Jenkins build, and Jenkins run all the unit tests, and then the process should end up with building and publishing a new version of Docker image for the application or set of applications. This Docker image goes to your Docker registry, which can be Nexus or can be Google container registry, or Azure or AWS or anything else, or Docker Hub. And that's where Spinnaker picks it up. So one of the Spinnaker's abilities to monitor new images coming, compare them with the regex expression that you give for tag, and if image qualifies the expression, so just start a new pipeline automatically. And here we have a two-step pipeline. In step one, Spinnaker deploys a new version to QA environment or the test environment, run tests, and those can be integration tests, end-to-end tests, and so on. Monitor the new version or behavior of the new version at the same time, and if results are satisfactory, move the new version to production. And in production, we use Spinnaker's Canary delivery capabilities to do what we just discussed as the process of Canary release. Well, couple more things on Spinnaker and Kubernetes. The version 2 provider, so-called of Kubernetes, which was, I would say, heavily driven by Google, allow us to do manifest-based deployments, which means that we can really define how our applications needs to be presented or deployed to Kubernetes clusters, and that's not only let's say deployment services or config maps. That's literally every Kubernetes object, including custom resources, can be deployed through the pipeline. Moreover, those manifests can be stored on each Google Storage or S3, and Spinnaker is able to monitor those storages as well as it does for Docker registry, and trigger the pipeline if one of the manifests change. So which gives you the flexibility to run the real GitOps process with Spinnaker itself. Yeah, I will skip this one for just a couple of words. So there's also, one of the things that Spinnaker is good at is a number of integration that it provides. I mean, obviously you can script everything by yourself, but with Spinnaker out of the box, you receive integration with Prometheus, Datadog, New Relic, and so on and so forth. There's pipelines, there's integration with Helm and Customize, and many more things that comes out of the box that otherwise you would need to implement using some of the scripting engines. So let's see how the Canary pipeline that we're going to look at today will work in Spinnaker. So as the first step, when our Docker image, when the new version of Docker image is published, we will deploy what we call vNext or Canary version to our production environment. And that's, again, considered that this application or this version went through QA or integration and maybe a staging environment where you ran integration and end-to-end tests. So that's not a replacement for testing. Now, as we have the vNext deployed to our production environment, we will go through the loop where we increase amount of traffic coming to the new version, monitor it for some time, and if everything goes well, increase traffic again. If we see that version does not behave as we expect it to behave, so we will just remove it and fail pipeline. Otherwise, at the end of the cycle, we just will replace the current version completely with the new version. So very similar to what we discussed in the diagram before. And with this, let me switch over to my screen and show you how that works. All right, hopefully you can see my screen. What I have on the screen right now is a Spinnaker user interface, and one of the applications that we have here is the simple demo application with the pipeline that we define, the Canary demo pipeline. And as I mentioned before, the pipeline is really very similar to what we discussed. So we deploy the new version of application here. We increase traffic to 5%. We run with this 5% increase for some time, and monitor the version. Then we increase traffic to 50%, run with it, monitor the version, and then if version behaves well on 50%, we replace the production version with it and kind of remove Canary. In any case, so if it fails on one of those stages, we'll skip future Canary stages, and we'll go straight into the delete Canary, and we'll fail pipeline at the end. So the application that I run here, the demo application, is very simple. It literally does nothing but just say webinar 2020. It's a simple Go application that serves index HTML over HTTP. So in order to run pipeline, let me do a change here, and then as pipeline runs, I will show you a bit more details of how it's structured. So let's make a quick change here on webinar. Let's add some. Oops, make some changes here. Well, normally I would, after I'm done with this change, I would, commit it to Git and push it to Git repository where Jen can pick it up and build a Docker image and so on and so forth. But that, that process itself may easily take 5, 10, 15 minutes. So to save some time, I will build a new version of Docker image here on my laptop and push it directly to Docker Hub. All right, so we've got a new image. Let's push it. And while we push it, so before Spinnaker picked it up, let me also start the monitoring here. So what I'm doing here, I will constantly hit our application endpoint for next 10 minutes to then see at the end if the whole release was disruptive or if we had any issues with accessing applications over time. So I will run one thread with 10 connections for 10 minutes. Now let's see here. So the image is published to Docker Hub. May take a minute or two for Spinnaker to pick it up. Refresh here. Good. Here we go. So as you can see, Spinnaker, identified a new image and started the process. So, and as we go through the process, looking at the bars, not very exciting. So I can show how the pipeline is configured in this Spinnaker. So we talked about different stages. Let's see how they are configured. So first one is configuration. What we define here really is the set of artifacts that we expect for this pipeline and triggers that we use to run this pipeline automatically. So for artifacts, we are looking for some manifest that we need to run the pipeline, which is the application definition. We need the Docker image, obviously, from Docker Hub. And then we have several manifests for Canary, for virtual services to switch traffic for Canary analysis that are also defined here. And then in terms of triggers, so we trigger this pipeline based on the Docker image, as we just seen. So as soon as it changes on Docker Hub, and I didn't provide any tag expression here, meaning that every new tag that is published to this Docker repository will trigger the pipeline. So now on deploy Canary, what we do here, and we simplified it a little, but we basically deploy a new version of application to our Kubernetes cluster. That looks a bit more complicated because we're on an older version of Istio, and majority of the stuff is not required anymore. But what is important here is that we just specify the image, and we don't specify a tag anywhere. So tag will be automatically substituted by Spinnaker based on the trigger that happened. So the next stage is so-called Canary 5%, and that's where we deploy our manifest, which is Istio Canary 05. The repository that we use is open, it's public, so you can go check on those manifests if you're interested to learn more. So the Istio Canary 5 basically defines, as we've seen on the diagram before, the traffic distribution for two different versions of application, one running as Demo and the other one running as Demo Canary, as 95 and 5%, where 5% would go to the Canary version. So next stage here is the actual observation. So that's where we integrate with Prometheus that we run as part of our Kubernetes clusters for metrics. And we describe here what we want to monitor and what metrics we want to monitor and what is the success rate for our metrics to pass through this stage. So in Canary configs that we defined here, which is demo Canary config, we only provided one metric, which is HTTP request total, and we want to see how many of them fail and how many of them pass. You can do any types of metrics you want. That can be, HTTP metrics, and can be application-specific metrics. Again, can be, pass, failed, or specific numbers, like the performance. So if you want to make sure that your new version is not slower than the previous version, so you can monitor the request duration metric and so on and so forth. So basically, that's your that's your field. So you can define whatever makes sense for your application here. Now, Canary 50 is very similar to Canary 5, where we just deploy a new manifest, which changes the definition for our virtual service, and when it changes the definition, we have 50% of traffic goes to production or the previous version, and 50% goes to the new version. And we use the same Canary config here, meaning that we still monitor the same metrics, but we changed the the definition of success, right? If on the previous stage we said 84 to 99, now we're saying, well, because we really, drive 50% of traffic here, and our previous version is kind of in the same range, so we say that 75% of successful requests would pass the stage, and then if we have less than 50, then we fail. And then if we go through this stage successfully, we'll run up to a big production stage, which basically replaces the version of production or replaces the production version with the new version, and then we'll deploy a Canary 0 manifest, which redirect again the 100% of traffic to the production version. And at this stage, the production version could be depending on how the release goes. Production version could be the new version, or production version could be the old version. And then we delete Canary. We don't, again, so in a successful pipeline, we don't need to run anymore because we replace production with it, and in a failed pipeline, we need to do it anyway. And here we either fail pipeline or make it successful depending on the result of Canary analysis stages. So, I mean, this pipeline is, I would say, a demo pipeline, right? So you don't have to do it exactly the same way, or better say you shouldn't do it exactly the same way. So this one simplifies things a little bit, specifically at the beginning and at the end. Where in real life, you would probably take what's called the baseline, right? So that's the same production version, deploy it to, some, well, probably side by side with the current production version, just to make sure that you compare clean current version with the new version, and don't compare based on, the fact, or don't have a special, or don't have any effect because the version was running for some time. And then at the end, the way we upgrade the version is not necessarily the right way to do it, but it's simplest to demonstrate the principles. All right, so let's see where our it sounds like we are done. That was only 8 minutes. Let's see here. Yep, so the version has changed. Let's stop here. So well, we did almost 1 million requests, and we had 16 reads that failed. Well, which this is the point where we, in order to provide the full real zero downtime, it's not enough to rely on Kubernetes or Istio only. We also need to do a better job on application itself. So as I mentioned, this application is quite simple, and one of the things it should do graceful termination. So meaning that if we as we deploy or switch from one version to the new version, the old version will be shut down, but at the same time it might still serve some HTTP requests. So the application itself must support the graceful shutdown, meaning that it has to stop accepting new requests, but properly complete old requests or current requests, which we don't do here. So and that's probably the reason for the 16 failed reads. But again, so that would be what 1,000% of the overall traffic, which doesn't look bad at all. All right. Well, I think I'm done here. Any questions on the on the subject?
So we do have a few questions here, so we'll go ahead and jump right into it. Can we do Canary releases with Jenkins as well?
Yeah, you certainly can. So as you saw, the real magic, I would say, happens between Kubernetes and Istio, right? So we use Spinnaker to automate or to script the flow. That's what we're seeing here. So we represent the logic here, as well as we use some of these capabilities that Spinnaker provides, like automatic Canary analysis, and we can hook into Prometheus here and some other tools. Now, if you use Jenkins, you obviously have the whole Jenkins groovy scripting capabilities there, and you can implement it yourself, or you can use Bash, or you can use Go, or you can use Chip, or whatever tools you use for deployment. But from our perspective, it doesn't make much sense unless you have very specific reasons, since you already have a tool or you all have all these capabilities in Spinnaker available out of the box.
Okay. And then another question we have is, does Kubler come with pre-installed Spinnaker?
Yes and no. So we in Kubler we don't enforce any specific CI/CD tooling. So we provide open source, reliable, production-ready Kubernetes, and which can work with any CI/CD tools that are available for Kubernetes today. So Circle CI, Spinnaker, Argo CD, or Flux, or whatever tool you use. However, we do recommend using Jenkins and Spinnaker for our customers, and we do have a predefined or preset Helm chart that deploys all these components, Jenkins, Spinnaker, and Nexus for registry for our customers, and that integrates well to the rest of Kubler infrastructure, meaning that the Spinnaker will leverage single sign-on capabilities that Kubler provides. Will automatically hook into for things like Canary analysis and so on. Will automatically hook into or connect to our Prometheus that we run for centralized monitoring. We'll provision automatically Grafana dashboards to monitor Spinnaker and Spinnaker pipelines themselves, and so on and so forth. So from this perspective, yeah, we do provide Spinnaker integrated with Kubler, but it doesn't come as default or as necessary CD tool that or required CD tool that you have to use.
Okay. And then one other question we had is, you demoed Canary analysis with production traffic. Do you also recommend running end-to-end tests during the analysis phase to increase coverage?
Well, this is not in production environment, right? So you don't want to load, send additional load to your production components, and with that kind of potentially affect your customers or users. So what we do recommend to do is, as you saw on the diagram, is to run end-to-end tests in QA or staging environments. Staging probably would be a better environment for that, since it has all the qualities and probably data from production environment. And then not to do Canary, because you don't need Canary for staging. You don't affect any real users. But as you deploy a new version, use the same metrics and the same techniques you do here for Canary analysis to monitor how this new version behaves or works in staging environment while you run your end-to-end and integration test.
Okay, and then we do have one last question. Can analysis be replaced with Flagger CRD?
That's an interesting one. So yes, however, there is no out-of-the-box support, and one of the things. I mean, let me explain a little bit more, right? So Flagger allows you to run Canary based on without Spinnaker based on Kubernetes components. So that's another component that you can install in your Kubernetes cluster, and as soon as you deploy the new version, you also have a definition of how you want to run Canary on it. Defined as the custom resource. And Flagger itself can do the whole logic that you've seen here, starting from deploy Canary to update production. So basically, that's the whole pipeline. You can still integrate it with Spinnaker and use Spinnaker's capabilities to, let's say, trigger based on the new deployment, or move things between environments and so on and so forth. The only thing that we haven't tried yet is the kind of feedback from Flagger. So it's as we monitor analysis here by ourselves, we know if analysis failed or succeeded. Now with Flagger, if Flagger succeeded, that's fine. If Flagger failed, Flagger will automatically return to the previous stage, but I'm not sure if we can read this information on the success or failure from Spinnaker to make further decisions. Like, for example, if we use Flagger for staging environment, do we want to, based on the success of Flagger, do we want to move the version to production environment or not?
Okay, well, thank you for that. We do want to say thank you for joining today's webinar. Feel free to reach out with questions or topic suggestions at the email provided, and we hope that you can join us next time.